Hello everyone, myself Dr. Santanu Kundu. I welcome you all to this lecture of soft computing technique. This is the third lecture of module 4. So in module 4, we have covered working principle and flow chart of genetic algorithm. We also discuss important terms of genetic algorithm like selection, crossover, mutation, fitness, etc. In this lecture, we will solve few examples. We will see some approach of genetic algorithm and also how to create initial populations. So this is the example one. So here we suppose a genetic algorithm uses chromosomes of the form X equal to A, B, C, D, E, F, G, H with a fixed length of 8 genes. So here A is a gene, B is a gene, and C, D, E, F, G, H are genes. Each genes can be any digit between 0 and 9. So it may be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 also. Let the fitness, that is the maximum value of individual X, that is the chromosome, individual X be calculated as Fx equal to A plus B minus C plus D plus E plus F minus G plus H. So let the initial population consist of 4 individuals, that is X1, X2, X3, X4 with the following chromosome. So that is the chromosome 6 is a gene, 5, 4, 3 all are genes. All these numbers belongs to 0 uh, and 9. So this is the X. So how to find the Fx1? So Fx1 will be like that, which is equal to A plus B, so 6 plus 5 minus C plus D, 4 plus 1 plus E plus F, 3 plus 5 minus G plus H, 3 plus 2. So here this is 11 minus 5 plus 8 minus 5. So you can check it is basically 9. So fx1 is 9. Similarly, you can find fx2. So as I said, fx1 is 9. So fx2 is 23. fx3 is minus 16. fx4 is minus 19. So question is that evaluate the fitness of each individual, showing all working and arrange them in order with fittest first and the least fit last. So as I said, as we have seen that the value of fx1 is 9. So similarly, value of fx2 is 23. That is A plus B minus C plus D plus E plus F minus G plus H. So that is 23. fx3 minus 16, fx4 minus 19. So we need to order. So the highest value, maximum value is the first rank. So that is x2. So order is x2. Next order is 9. So that is x1. Next is minus 16, x3, and the last one is x4, which is minus 19. fx4 is minus 19. So that is the last x4. So second question is that the question of B. Perform the following crossover. So we need to do the crossover. So cross the fittest two individual using 1 point crossover at the middle point. So we need to solve the 1 point crossover at the middle point. So what is the middle point? So check it. So that is A, B, C, D, E, F, G, H. So that is the middle point. So here we need to uh, apply the crossover, 1 point crossover at this point of the fittest two. So that is x2 and x1. So x2 is 6, 5. So x2, that is x. So x2 is 8, 7. So we need to do the crossover fittest two individual. So fittest first one is x2, second is x1. So 8, 7, 1, 2, 6, 6, 0, 1. That is the x2, and x1 is 6, 5, 4, 1, 3, 5, 3, 2. So after B, so this part in offspring 1, this part will go to offspring 1 and this part will come to offspring 2. So here offspring 1 is 8712, then 3532, offspring 2 is 6541, 6601. The second question of the crossover is that second question of the in of B is that cross the second and third fittest individual using 2-point crossover between B and A. So that is A, B, C, D, E, F, G, H. So here we need to the 2-point crossover. So of the second and third. Second, you have seen x1 is second, x3 is the third. As the order is like that, the order you have studied, which is x2, then x1, then x3, then x4. So second and third, so that is x1 and x3. So that is x1 6 5 4 1 3 5 3 2, and x3 is 2 3 9 2 1 2 8 5. So here you need to do the crossover. So this part will come here and this part will goes there. So that is 6 5 9 2 1 2, and this is 3 2, and this part will come here. So they will get it 2 3, then 4 1 3 5, then 8 5. So we got this 2-point crossover and x1 and x3. So that is offspring 3 and that is offspring 4. Now the question 3. So cross the first and third fittest. So first you know that is x2 is first, x3 is third. So cross the first and third fittest individual, that is x2 and x3, using a uniform crossover, that is exchange. So in the simplest case, uniform crossover means just a random exchange of genes between two parents. We need to swap the gene position. So for example, we may swap genes at position A, D, F of x2 and x2. So that is A, this is D. So I'm writing that x2 is these things, 8 7 1 2 6 6 0 1. So that is A, then we see D, and then E, F here. Similarly, x3, that is basically 2 3 9 2 1 2 8 5. So here we need to check and 2. So offspring 1, that is exchange between the genes. So you will get the exchange, you will get here 2 8. So exchange here you will get it 2 8. 7 3 will be as it is, then 1 9 will be as it is. Now 2 and 2 change, 6 1 will be as it is. Now 2 and 6 is swap their positions, 0 8 is same, 1 5 is also same. So O 5 is the offspring 5 is that 2 7 1 2 6 2 0 1. Offspring 6 is 8 3 9 2 1 6 8 5. So we have done 3 crossover. First one is the single point, second one is the double point, and third one is the uniform crossover. So next question is that suppose the new population consists of 6 offspring, that is O1, O2, O3, individual received by the crossover operation in the above questions, that is question number 2. Evaluate the fitness, that is question number B. Evaluate the fitness of the new population showing all working as overall fitness improved or not. That is the question is that has overall fitness improved or not. So consider the 6 offsprings what we have got, what we have obtained. So consider 6 offspring. First one is that 8 7 1 2. So if we take the reference of first one, that is 8 7 1 2 3 5 3 2, like that. So these are the 6 offspring. First one 8 7 1 2 3 5 3 2. Second one is that 6 5 4 1 6 6 0 1. Third one is that 6 5 9 2 1 2 3 2. And fourth one is that 2 3 4 13585. Fifth offspring 271262001, and the sixth offspring is 8392168. So we need to find the fitness of that. So what is the value of F01? So F01 will be A plus B minus C plus D plus E plus F minus G plus H. The value of spring is that 8 plus 7, that is 15, 1 plus 2, so this 3, so minus 3, then 3 plus 5, so plus 8, 3 plus 2 is minus 5, so you will get it 50. So F01 is 50. So similarly, you will get F02, that is 6 plus 5, 4 plus 1, 6 plus 6, minus 0 plus 1, so that is 17. O3 minus 2, F of O4 is minus 5, F of O5 is 13, F of O6 is minus 6. So here the minimum value is minus 6, and in that case the minimum value is minus 19. So F export. So as the minimum value here F of O6 is minus 6, and minimum value of F export, that was minus 19. So you can say the overall fitness has improved. So question D is that by looking at fitness function and considering the genes, can only the digits between 0 and 9 find the chromosome representing the optimal solution, that is with the maximum fitness. So find the value of the maximum fitness. So maximum fitness, you know, where we add it, we'll add the maximum value, where you subtract to write 0. So where we add it, so that is the 9, subtracts, we can write 0 0, we add it 9 9, so we add it 0 0. So maximum, so the value, the maximum, the chromosome which contains maximum value is that the chromosome which contains maximum value is 9900 and maximum value will be these things: A plus B minus C plus D plus E plus F minus D plus H. So you will get. So question is that by looking the initial population of the algorithm, can you say whether it will be able to reach the optimal solution without mutation operator? Without mutation operator. So see, the all genes are start with 6, 8 like that. So if we do the crossover, we're not able to obtain 9 9. So question is that answer is that. So answer is that no, the algorithm will never reach the optimal solution without mutation. The optimal solution is X optimal. We have seen that is 99009900. If mutation does not occur, then the only way to change gene is by applying the crossover operator. Regardless the way crossover is performed, it is only outcome is an exchange of genes of parents at certain position in chromosome. This means the first genes of the chromosome of children can only be the either 6, 8, 2, or 4. That is first genes of X1, X2, X3, and X4. And because none of the individual in the initial population begins with gene 9, the crossover operator alone will never be able to produce an offspring with gene 9 in the beginning. So one can easily check that a similar problem is present at several other positions. Thus, without mutation, this GA will not able to reach the optimal solution. So thing is that within genetic algorithm, we will not get the exact solutions, will get some closer to the exact solutions. So now second problem, in the last one we have discussed crossover fitness and etc. So here in this example we will try to understand, the encoding and how to find the fitness value. So we are considering a traveling system we're considering a traveling salesman problem. There will apply the only the encoding. So you know the traveling salesman problem. So there are list of cities like that A B C D. So from A to A not required. So A to B cost is 2. From B to C 5. C 8. From A to A not person. A to A is not required. So A to B is 2. A to C is 5. A to D is 7. A to E is 1. Similarly, B to A is 6, B to B is not required, B to C is 3. So you know the uh, traveling salesman problem. So here we considering 9 initial population, that is A, E, C, D, B, A. So A, E, C, D, B, A. So A to E is 1, E to C is 2, C to D is 4, D to B is 4, and B to A is 6. So if you add, you will get 70. So here it is 70. Similarly, if you consider A, B, E, C, D, you will get 22. If you consider A, C, D, E, B, A, 23. A, B, D, C, E, A 24, and so this A, E, B, C, D, A 25 like that. So you know that is the minimum problem. So we have seen that according to the fitness criteria, we are selecting four values, that is 17, 22, 23, 24, which are the least values. So we are considering these values. So we are considering chromosome 1. So I am writing it C1, which is equal to A, E, C, D, B, A. We're writing chromosome 2, which is A, B, E, C, D, A. Chromosome 3, which is A, C, D, E, B, A. Chromosome 4, which is A, B, D, C, E, A. So after that we can do the crossover mutation. So in this way we'll proceed, and after few iterations we'll get our desired result. So that part we'll do in further in future classes. Now try to understand one encoding technique. So for 0 1 knapsack problems. So as you know the knapsack problem, so there are n items. Each item has its own cost Ci and weight Wi. So there is a knapsack of total capacity W. The problem is to take as much as item as possible, but not exceeding the capacity of the knapsack. So this is an optimization problem, can be better described as maximize CI WXI subject to xi wi less than w. So summation of xi wi less than w. So here xi is 0 and 1. If we take the item that is 1, if we're not considering, then it is 0. So this is one instant of the knapsack problem. So that is item 1. So that is, so this is, you can consider as item 1. This is item 2. This is item 2. This is item 3, and this is the knapsack. Maximum weight is 50. So cost is $60, $100, and $120. So if I take this item, we'll write it 1. If we not take, then this item will be 0 like that. So here we are applying brute force approach to solve the problem, can be described as follows. Select at least one item. So first item we select, then second item we select, then third item we select. So this is a chromosome 1, this is chromosome 2, this is chromosome 3. So there is first, second select, first and third is select, second and third is select, and all are select. So here for n items there are 2 to the power n minus 1 trial, you know that is NC0 like that. So NC1, then NC2, then ultimately NCN. So you'll get 2 to the power n minus 1 trials. So 0 means item not included, 1 means item included. So that is the one encoding technique. So here the first item is selected, so you can write it 1 0 0. Second is selected, write it 0 1 0. Third is selected, write it 0 0 1. First and second selected, so that is 1 1 0. So here for this item we can write it first is selected, so that is, so here we can write that the first is selected, so we can write it 1 as the item, as the first item is selected, so here we can write it 1 0 0. Here second selected 0 1 0, third selected 0 0 1, first second selected 1 1 0, first and last selected 1 0 1, then it is 0 1 1. Here all are 1 1 1. So this is the encoding technique for the 0 1 knapsack problem. Then we apply our then we can apply genetic algorithm to get the better solutions. Today we have seen some problems in which we can apply genetic algorithm. So question is that consider any maximize problem. So suppose maximize fx equal to x plus y plus z plus w minus 30. X belongs to 0 to 10, y belongs to 0 to 10, z belongs to 0 to 10, and w also belongs to 0 to 10. All belongs to the integer. All are integer, I mean the natural number. So find 4 genes. So assume 4 chromosomes. So that is chromosome 1. So assume any 4 chromosome, chromosome 1, chromosome 2, chromosome 3, chromosome 4, and apply the crossover technique. So by assuming any 4 chromosomes, C1, C2, C3, C4, find offsprings. So this is the so this is the references for today's class. Thank you.